This is section 3.2, solving quadratic equations. There are two sections of 3.2, so just keep that in mind. So when you solve a quadratic, there's three types of solutions that you can have. You can have two solutions. That is where the quadratic crosses the x-axis twice. Okay, so those two would be your solutions. You can have one solution, and what actually happens there, the vertex, the very low point or the very high point just touches the x-axis, so you have one solution. And then you have a scenario where it never touches the x-axis. It would be a non-real solution. All right. So the old way to solve these was factoring. The calculator does actually do this. There's a function on there for it. So hopefully you have your note guides printed out. If not, these are the three equations that I'm going to be working on in the calculator. So if you want to stop the video and write them down real quick, if you don't have this printed out, and I'll flip to the next page before I move on. All right, and again, real quick, let me flip back. There is a place here for you to make calculator notes, and you can stop this as needed. So you're on the main screen where you would just add and subtract things. You're going to hit menu. You're going to go to number 3, algebra. Again, if you have the CAS, yours is going to be a different lineup. You want to go to polynomial tools. Technically, you can actually use any three of these just to stay consistent and not have to do different ones for different problems. I'm just going to stick with complex roots of polynomials. It also solves for real roots as well. So complex roots will get regular roots and real roots. So let's use that one. All right, so I'm going to put this equation in. It's going to be a little bit different than numerical solve. The equation is equal to 0. Now with C poly roots, you don't put an equal sign. Everything has to be on one side. It has to be equal to 0. You're not going to put the equal in. You're going to put comma X though at the end like we do with numerical solve. And then you hit enter. And that has two solutions. So that means that quadratic, if you were to graph it, it's going to cross at -2 and +5. It's not an ordered pair. It's two separate solutions to the quadratic. And I'm just going to grab it just so you can see. So we're crossing, there we go. We're crossing here at -2 and over here at +5. Okay, so those are the two solutions that we got. I'm going to do the other ones and then I'm going to show you how to write those out. So menu, algebra, polynomial tools, complex roots. All right, let's put this equation in without the equal sign and put comma X at the end and hit enter. And this one will cross the x-axis at 3 and 8. Now the next one on this has S's instead of X, which is fine. You would just have to put comma S at the end. I just prefer to stick with X's. So menu, algebra, polynomial tools, complex roots. I'm going to leave them as X's. That's what I prefer. 6. If you decide to leave it as an S, you have to do a comma S at the end. Okay. So you can see it doesn't matter if you have to convert it to an x, but you have to tell it what to solve for. So let's go back to the note guide real quick. So in my math lab, I don't know if they have x is equal to, but you're going to put in -2, 5. You do not put a parentheses because it is not a point, it is not an ordered pair. These are two separate solutions. Or you could put it as 5 and -2. So the order doesn't matter because it's just telling it you have two different solutions. The calculator is going to put it from least to greatest. So let's go down here. Let's look at these two. Now, what's different with this one on the top left? Right, it's not equal to 0. This has to be equal to 0 in order for you to use C polyroot. So we're going to move the 4 to the left by subtracting it. And then this left side here is what you're going to put in the calculator. It has to be equal to 0. And then the one on the right here, that's fine. It's still equal to 0. The 0 doesn't have to be on the right. It can be on the left. So I'm going to flip over to the calculator and put these top two in. First one's -2 and +1/3. And this one has t's. I'm going to change them to x's. You're welcome to leave them as a t, but if you do, you need to put comma t at the end and not comma x. Back to our note guide. So this crosses the x-axis at -2 and +1/3. And this one crosses the x-axis at 3/4 and 4. All right, so these last four ask you to find the exact solutions in complex numbers. So we need to find a complex solution is what we're looking at. The only one that's going to be an issue, let me pull this down real quick. All right, so if you don't have the note guide, you can write these down. You may want to pause this if you're writing it down. The only thing that's going to be odd is this one. So let's look at that before I flip over to the calculator and put these in. Now the other three are set to 0. So the issue here is, this is the problem here. It doesn't recognize that square. The programming's not such that it will take care of that for you. So we do actually have to multiply this out. So x minus 3 squared is x minus 3 times x minus 3. All right, so we're going to multiply this. So x times x is x squared. X times -3 is -3x. Then we're going to do the -3 times everything. So I have another -3x. Then -3 times -3 is a +9. These two terms are the same because they both have a single x on them. So negative 3 minus 3 is going to give me negative 6. And remember, these need to be equal to 0. So let's add the 36 to both sides. So x squared minus 6x plus 45 is equal to 0. And then again, this left side here is what you're going to need to put into the calculator. So let's flip over to that. And we'll start putting these in. Now these are complex roots. You need complex solutions. So you couldn't use real roots. We could use real roots with the other one, but for complex solutions, we'd have to use complex roots. But again, complex roots will also find the real roots. So I just stick with that one so you don't have to swap between the two. So that's our first one we had. And that's going to give me negative 11i and positive 11i. And I'm going to flip back over to the note guide when I'm done with the other three and show you how to write these out. So with the I, that means this is an example of the one that it never touches the x-axis. This is the one we had to, I think, this kind of work out. So 3 minus 6i and 3 plus 6i. That's negative 5 minus 7i and negative 5 plus 7i. So that's negative 3 minus 7i and negative 3 plus 7i. So I'm going to flip back over to the note guide. So it's negative 11i, comma, positive 11i. Again, no parentheses. It's not an ordered pair. It's two different types of solutions. This calculator keeps us from having to use the quadratic formula. I don't know if you remember that. You don't have to write this down. That's the quadratic formula. It keeps us from having to use that. Okay. All right. And this one, x was 3 minus 6i and 3 plus 6i. When you type an I, just a lowercase I, into MyMathLab, it will bold it. It knows it means I is an imaginary number. It's the square root of -1. We don't really get into that in depth. All right, so this was negative 5 minus 7i and negative 5 plus 7i. And then this one was negative 3 minus 7i and negative 3 plus 7i. Now, generally, we usually write it like this, plus or minus. That's the same thing. That's telling me it's two separate answers. It's plus minus. They do have a plus minus option in my math lab, but I generally find that students like it separated as two separate answers, so I just stick with that. All right, and that is it for this section of 3.2.